So today we're going to talk about angles of elevation and depression. And basically, angles of elevation, I think most people generally understand because usually there's like a ground or like water level or something like this. And it's just how much does it rotate upward like that. Now, angle of depression is a little weird because you have to draw this like imaginary horizontal line like from where you're measuring. Like this seems to be from this guy's eye. And you have a horizontal line like that. And it's the amount that the angle goes down like that. Now, bonus fun. This is a horizontal line. This is just a horizontal line as well. That would mean that these two lines here are parallel to each other, which means that the angle of elevation in this sense is the same as the angle of depression because alternate interior angles are congruent when lines are parallel. So these two angles in this case are actually exactly the same. So with this thing, we have an airplane at an altitude of 1,200 meters. The angle of depression to the runway on the ground is 28 degrees. What is the distance from the plane to the runway? How far does the plane have to travel? So first, let's start by drawing a quick picture. Okay, so you couldn't do much better. All right, maybe you could. You probably could. All right, whatever. So there's a picture. There's a plane. There's a runway. And we know that the plane is 1,200 feet, or 1,200 meters rather, above the ground. So this height here is 1,200 meters. The angle of depression, so we got to draw this fake horizontal line right here. The angle of depression is 28 degrees. Now, this looks unhelpful, right? Because this 28 degrees isn't in the triangle that I see right here. But remember, since this is parallel to this, the angle of elevation right here is an alternate interior angle, and therefore it means that this is also 28 degrees right here. And that's what's really going to help us because that's part of this triangle right here. And then the last part is we have to find the distance, so how far this thing is going to fly. So let's put an X on the hypotenuse here. And now let's just solve it the way we normally would solve a right triangle problem, looking for a side. So we have an angle, we have a side, we're looking for a side, we're looking for the hypotenuse specifically, and the 1,200 is the opposite. So we have opposite and hypotenuse. That sounds like a sine problem to me. So we have sine of 28 equals 1,200 over x. Cool, cool. Put it over 1, cross multiply. We get, I'm going to put it over on the right here just to avoid hitting some things. So we get sine of 28 times x equals 1,200. Divide by sine of 28 on both sides, cancels it out here. Divide by sine of 28, and using your calculator, we get that x is about 2,556 meters away.